Good afternoon, class. We are looking at Chapter 2 review, limits and derivatives. Exam 1 covers 2.1 to 2.8. Here's 2.7 to 2.8, 2.7 derivatives and rates of change, 2.8 the derivative as a function. (2.7) derivatives as and rates of change tangents. Given y equals f of x and point P having coordinates a and f of a, the slope of a secant line PQ is average rate of change. So when you pick 2 points on the curve, you connect them, it creates what we call a secant line, and the slope of that line is easy to find, rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If we go with this, f of x minus f of a over x minus a, that's the same thing. If you look at this one, we have the distance, this is a, we have the distance a, h, resulting in a plus h here. So f of a plus h minus f of a, okay, that would be the rise, and the run would be h, which is a plus h minus a. If you call this b and this is b, f of b, then it's this formula, meaning they are the same. They are all rise over run. They are also known as the DQ, the difference quotient. Okay, and it is easy to find the slope of a secant line because we have 2 points. What about this point? As we get closer and closer to it, becomes the tangent line. So the tangent line is the limiting position of the secant line PQ as Q approaches P from each side, actually, from both sides. Slope of a tangent line, also known as instantaneous rate of change, m of tangent line, is this limit of m of PQ as Q approaches P. So this slope as a Q approaches P. Or if you look at this one, f of x minus f of a over x minus a as x approaches a. So remember, this is x before putting b, as x approaches a. If you look at this one, as h approaches 0, they all mean the same thing. And so f prime of a is the limit of f of x minus f of a over x minus a as x approaches a, or limit of f of a plus h minus f of a over h. That's normally what we use at a specific point. And we remember the equation of lines are standard from ax plus by equals c. Point slope is y minus y1 equals m times x minus x sub 1. And slope is y equals mx plus b. So the equation of a tangent line at this point, okay, this point, we have a comma f of a, right, at this point, this line. So y minus f of a equals f prime of a times x minus a. Just following this, where f of a is y sub 1 and f prime of a is m. There is nothing brand new you have to memorize. Find the derivative, aka also known as instantaneous rate of change of f of x of the function f of x equals x squared minus 8x plus 9 at x equals 5. And we have to go with the definition for now. Later on, we take the easy way out. But for now, using the definition, we use one of these two. For example, if we stick with the second one, f of a plus h minus f of a over h, and we take a limit as h goes to 0, a is 5. All we have to do, evaluate the numerator and simplify. We will get 5 plus h squared minus 8 times 5 plus h plus 9. And then we plug in 5 squared minus 8 times 5 plus 9. That's the numerator. Now, I'm assuming nobody has any problem with that. Pretty straightforward. A plus b squared is a squared plus 2ab plus b squared. So 5 plus h squared is 5 squared, which is 25, plus 2 times 5 times h, which is 10h, plus h squared, according to this. Minus 40 minus 8h plus 9 minus, now this is 25, this is minus 40, this is minus 9, and we can apply the negative, or we can simplify it either way. So I'm applying the negative. So this one is 25, 10h, h squared. This is minus 40, minus 8h plus 9, minus 25, plus 40, minus 9. I put it in this format so we can easily see what happens here. 25 minus 25. 40, negative 40 and positive 40. Positive 9, negative 9. They cancel each other. So what is left in the numerator is 10h minus 8h, which gives us 2h plus h squared. We can factor the h out. We get the limit of 2 plus h as h approaches 0, and the answer is 2. Please understand this can be done pretty fast using formulas, but we are going with definition. We are going with definition. We are going to use this definition to find the derivative of f of x equals 5x plus 1. So f prime of x is the limit as h approaches 0 of fraction bar f of x plus h. That means 5 times x plus h plus 1 minus f of x, just 5x plus 1 over h. So one more time, we are coming up with f of x plus h, which is 5 times x plus h plus 1, and then minus, just write this. Now, this is 5x, 5h plus 1 minus 5x minus 1. 5x and minus 5x cancel each other. 1 and negative 1 do the same thing. So the numerator is left with 5h. H cancels out the h. Limit of 5 as h approaches 0. It's a constant. The answer is 5. F of x is 2 over x. So the limit as h approaches 0 of 2 over x plus h. That's f of x plus h, everybody, minus 2 over x over h. Is a complex fraction. By the way, if you plug in, this becomes 0 over 0, this becomes 0 over 0. That's the indeterminate form. And the technique in this case is LCD, the least common denominator. The numerator has two fractions, so the product of the two denominators, x times x plus h, is the LCD. You multiply and divide by it because this expression must be equal to 1, and it is. Since h is approaching 0, it is the denominator of 0 that creates a problem. So you never distribute. You keep this as a product, h times x plus h. The numerator, however, you multiply to simplify them as follows. If you multiply these two, x plus h cancel out, you get 2x. If you multiply these two, minus 2 times x plus h. So I'm assuming we have no problem with algebra. So one more time, this, and you multiply x plus h goes away 2x, and these two minus 2 times x plus h. So you distribute this one, this is 2x, this is minus 2x, this is minus 2h. These two cancel each other, we get negative 2h in the numerator. H and H cancel each other. So we have -2 over x times x plus h, and we want to take the limit as h approaches 0. Now if I plug in 0, this becomes x, and x is x squared, so -2 over x squared is the final answer. So f prime of x is -2 over x squared using definition. Find an equation of a tangent line to the graph of the function f of x equals square root of 3x plus 1 at x equals 8. To do so, you need two things. You need the slope. That means you have to find f prime of x first. And you need a pair. And to find the pair, you just plug in. So f prime of x and then plug in 8. You have two choices. You can calculate f prime of x and then plug in 8. Or just calculate f prime of 8. Let's go with the general format and let's use this definition. So f prime of x is square root of 3 times x plus h plus 1 minus the same thing, square root of 3x plus 1 over h. So by definition, you get this one, everybody. If you plug in 0, you do get 0 over 0. I want you to know that. And the technique is the conjugate, as we've learned. So the conjugate of the numerator, that means this plus this. So you're going to multiply and divide by it because this expression is equal to 1 and is acceptable. Again, since h is approaching 0, the problem is the h in the denominator, so you don't never multiply, but rather you say h and then put this in a parenthesis, you don't distribute. What happens here? You have a minus b times a plus b. The answer is a squared minus b squared, which means you're going to square this so it comes out, minus you're going to square this and it's going to come out. And as I mentioned, the denominator, you don't do anything, h and then times this. So all we have to do is simplify the numerator. 3x plus 3h plus 1 minus 3x minus 1. 3x and negative 3x cancel each other, positive 1 and negative 1 cancel each other. So the numerator is 3h only, where h from the top and the bottom cancel each other. We are ready to plug in 0. If I plug in 0 here, this becomes 3x plus 1. And therefore, these two become identical if I plug in 0. By the way, you carry the limit sign. Notice over here, when I replace the h with 0, I drop the limit sign. This is where you drop it. So 3 over the same thing times 2. In other words, 3 over 2 square root of 3x plus 1. This is f prime, not the slope. What makes it the slope? Plug in 8. And I hope you see that if I plug in 8, I get 3 times 8. Let me show you. If I plug in 8, I get 3 divided by 2 square root of 3 times 8 plus 1. So 3 times 8, 24 plus 1 is 25. So we have 3 over 2 times square root of 25, which is 5, and that makes it 3 over 10. What about 8 and 5? Plug in 8 here, and that gives you 3 times 8, 24 plus 1, 25. The square root is 5. Okay. And so y minus y1 equals m times x minus x of 1. So y minus 5 equals m 3 over 10 x minus 8. Very straightforward, class, okay? You don't have to memorize the formula for the tangent line, but rather just the point slope. And this is 3 over 10 times x minus 24 divided by 10 or 12 over 5. 3 times 8, 24 divided by 10, 12 over 5. And negative 5 is going to move to the other side, becomes positive 5 or 25 over 5. Assuming nobody has any problem with fractions, okay? And therefore we end up with this as the answer. And you can check with this pair, and basically it says this process is done correct. It doesn't say anything else, okay? If you do that. The graph of a function f is given. Use it to sketch the graph of the derivative f prime. So to do so, we need to know a few things. Relative max or mean happens when f prime is 0. So peaks and valleys. F prime is positive, f is increasing. When the function is increasing, f prime is positive. When it's decreasing, f prime is negative. Remember, it represents the slope of a tangent line at a given point. So take a look at important parts. This means the slope is 0. This means the slope is 0. This means the slope is 0. Never mind that. We'll discuss that in a moment. So I want to show you how we roughly arrive at the answer. So over here, the function is decreasing. F prime is negative. Over here, this part, the function is increasing. F prime is positive, okay? And so what happens roughly, this corresponds to 0, right? This corresponds to 0. This corresponds to 0. And if we look at this part, everybody, it says decreasing f prime is negative, so it has to be below the x-axis. So something like this. Okay, it doesn't have to be exact. From here to here, it's increasing. So from here to here is above the x-axis, increasing above the x-axis, but at a is 0, at b, or a prime and b prime becomes 0. So it goes up and it comes back down. Maybe I should go with the green one. So it goes up and it has to come back down. And again, this part is below. Now, this part is below the x-axis because f prime is negative. Okay, f prime is negative. And so it goes below and it has to come back up. And then over here is increasing, so it's above the x-axis. As far as what they did here, they did their best to draw a tangent line, and they picked up 2 points. Let me clean the mess. So they picked 2 points on this, like this one and this one, and they evaluated the slope. So that means This should correspond to 5, comma 3 halves or 1.5 for the derivative, and the graph looks like that. Okay, everybody? Again, this is 0, this is 0, this is 0. This part is decreasing below the x-axis, decreasing below the x-axis. Increasing and increasing is above, and this point 5 and 1.5 or 3 halves. The graph of a function is given, use it to sketch the graph of a derivative f prime. If the given is a line, easy, calculate the slope. Whatever the slope is, draw a horizontal line with that equation. The slope is 7, y equals 7. The slope is -2, y equals -2. So we need to calculate the slope, and we pick 2 pairs. This is easy, everybody can recognize it. And this one, I hope you recognize, this is 1 and this is 3 because this is 6. The scale along the x and y axis do not have to be the same, and they are not. And so 3 minus 0 over 1 minus 0, that gives you 3. It's easy to calculate it. So the line y equals 3 is the answer, which is a horizontal line, and we are done. What about this one? Again, at this point, we have slope equal to 0 at this point and at this point. The reason why, because those are peaks and valleys. So corresponding to those 2 points, we have these 2 points on the x-axis of its derivative. The next thing is this is increasing, so is this one. So increasing means f prime is positive, so it's above the x-axis, above the x-axis. And this part, f prime is negative because it's decreasing. Therefore, it's below. But it has to come back up. Now, what I have, of course, it's not as good as this one, so I'm going to erase mine, and so you can see that. What about this? Quickly, we recognize this corresponds to 0 on the graph of f prime of x. F prime is negative here below the x-axis. Okay. So something like that. This part is increasing. F prime is positive, so above the x-axis, something like that. It looks like that. Again, definitely not to scale. The one I drew for you, just wanted to give you an idea. Look at important parts. So again, what are you looking at? Where is f prime 0? That's what you look at. Where is f prime positive? When the function is increasing. Where is f prime negative? When the function is decreasing. Okay, pay attention to those key points and you have the graph. How can a function fail to be differentiable? There are 3 ways. Number 1, we have a corner. Number 2, we have a discontinuity. And number 3, we have a vertical tangent line. So A, corner or kink. The graph of f has no tangent line at this point. The left and right limits are different. So where do you draw a tangent line? If f is not continuous at A, then f is not differentiable at A. So at any discontinuity, for instance, a jump discontinuity, f fails to be differentiable. So where do you put the tangent line again? And in the case of a vertical tangent, then the limit of absolute value of f prime of x as x approaches A is infinity. Remember, vertical lines, we say that the slope is undefined. The graph of a function f of x has a vertical tangent line at the point a comma f of a, if and only if. When we have I, f, f, that's what it means. If and only if the limit of f prime of x as x approaches a is negative infinity, and the limit of f prime of x as x approaches a is infinity. So when the derivative becomes either negative or positive infinity, we are dealing with a vertical tangent line. Both sides have the same result, negative or positive infinity. Finally, we have what's called a cusp. The limit of f prime of x as x approaches, for example, 0 from the right is infinity, but from the left, 0 from the left is negative infinity. So when the graph of the function becomes vertical and then virtually doubles back on itself, such pattern signals the presence of what is known as a vertical cusp. In general, we say that the graph of f of x has a vertical cusp at a comma f of a. If the limit of f prime of x as x approaches a from the right is infinity, but from the left is negative infinity, or vice versa. Okay, both sides do not have the same result. Vertical tangent line, both sides are either positive or negative. Cusp, one side is negative, one side is positive. The point and the most important thing is that the function fails to be differentiable. That's all you need to know. So for example, we want to know the graph of a function f is given, where and why the function is differentiable. Let's start with this one. At x equals 0, clearly we have a discontinuity and therefore it fails to be differentiable. And this is number 3. Clearly at x equals 3, there is a vertical tangent line. If you don't see it and you see it's a sharp corner, I'm okay with that. But I'm going to show you the difference between the vertical tangent line and a sharp corner in a moment. If you look at this one, obviously, this number is -1, so we have a discontinuity because we have a discontinuity, therefore it's not differentiable. Or you can even say you have a jump. Also at number 2, we have a sharp corner. Now, what is the difference? At 2, you can see you have sort of like a V shape, or if it's an upside down V shape. But as you can see, this seems to go up and this seems to go up. So that's the difference. Both of them seem to go completely up here when they get together. But this one is a V shape. You can clearly see it's a V shape. That makes it a sharp corner. The graph of a function f is given. Use it to sketch the graph of the derivative f prime. So the very first thing I want you to notice, we have 1, 2, 3, 4 line segments. That means for each line segment, we are going to calculate the slope first. And assuming, for example, we had only this one, and whatever the slope is, it's a horizontal line with that equation. The slope is 10, y equals 10. The slope is -5, y equals -5. That's the idea because they are all line segments. So let's throw in numbers. Let's assume those are the numbers, and in case it's hard to read it that way, let's assume those are the numbers. You calculate the slope rise over run. So for example, for these two, we are going to say 0 - 1. over -1 minus 3, which makes it plus 3. The numerator is -1, the bottom is +2, so we have -1/2. Which means if I calculate the slope here, you can do the rest. Clearly, this one is the opposite of that. That's +1/2. This is easy to calculate, is 1, and this is -1. So I'm going to assume you can calculate all those slopes easily. Now, if you look at the very first one, y equals -1/2, class, just for the sake of argument, it's this line, and this is not too scale, y equals -1/2. If this line continued indefinitely, that would be the answer, and we are done. But it's not. So what happens is that it stops here. And so you have to have a hole here. So what happens is we have this part of it. And we do the same thing for m equals 1. This is m equals 1. We just have it from here to here. M equals -1 from here to here, and m equals 1/2. So let me clean up the mess. So this one for y equals -1/2. Why do we stop here? Because we stop here. Why is there a hole? Because it's a sharp corner. We write the rest of them. Y equals 1. Y equals 1/2. Y equals -1. And again, please understand this one. Sharp corner here, sharp corner here. This one, sharp corner here, sharp corner here. And the last one, sharp corner here. That's how you come up with those answers. So that's the final answer. All right, we want to find the limits when we have the limit of square root of 1 plus 4x to the power of 6 over 2 minus x cubed when x approaches negative infinity. So how do we deal with a case like that? Remember, when we have a rational expression, we divide by highest degree term in the denominator, which seems to be x cubed. How can we do that? Let's go inside, and this is one technique. You can take x to the power of 6 out from the inside. This becomes 1 over x to the power of 6 plus 4, and then x to the power of 6 can come out. Now, here's what you should be very careful. In case of the limit as x approaches infinity, for x larger than 0, square root of x squared, which is absolute value of x, becomes x. And in case of x approaching negative infinity, for x less than 0, square root of x squared, which is absolute value of x, becomes minus x. Again, I'm reminding you, minus x doesn't mean negative. That means the opposite of x. Therefore, x cubed is equal to square root of x to the power of 6 if x is positive. However, if x is negative, becomes negative square root of x to the power of 6. And because x is approaching negative infinity, you can take this out, but you have to change it to minus x cubed. So pay attention to this. That's why we get this one. Now, we can divide everything by x cubed. So if I divide the top and the bottom by x cubed, what happens is that this goes away. This becomes 2 over x cubed. This becomes minus 1. So we divide it by x cubed. This went away. This is 2 over x cubed. This is minus 1. And now x is approaching negative infinity. Whether x approaches infinity or negative infinity, 1 over x to the power of 6 becomes 0. 2 over x cubed becomes 0. So you have 2 With the negative outside, you have negative 2. The bottom is negative 1. And the answer is therefore positive 2. So you want to be very careful when you handle a case like this. We want to find the limit of x squared over a square root of x to the power 4 plus 1 as x approaches infinity. And again, you're dealing with the square root. However, we remember this. And so first and foremost, we're going to take the x to the power of 4 out from the inside. And it just comes out as x squared because x is positive. Needless to say, because this comes out as x squared and x squared has an even exponent, even if it were negative, would become positive, okay? But just for the sake of argument, if it were x to the power of 6, would come out as x cubed positive, okay? But x to the power of 4, you don't have to worry about it. Either way becomes x squared because x squared is positive. And so with that being the case, I can divide the top and the bottom by x squared. I can drop this 2. When I do that, I replace the top with number 1. And now, when you apply the limit, this is 1 and this is 0, right? Okay. If you apply the limit, in other words, infinity makes this one go to 0, 1 over square root of 1 plus 0, or simply 1. Find the derivative of the function. Again, we are using definition. Again, there is an easier way later on we discuss. For now, we are using the definition. The limit of f of x plus h minus f of x over h as h approaches 0. And that means the limit as h approaches 0, the numerator is 7 times x plus h quantity squared plus 4 minus this expression over h. So we just write the numerator in this manner. Very easy. So x plus h quantity squared is x squared plus 2xh plus h squared. We multiply it by 7, we get 7x squared plus 14xh plus 7h squared plus 4 minus 7x squared minus 4. All we are doing, simplifying the numerator, everybody. So 7x squared and minus 7x squared, 4 and negative 4 cancel each other. So we are left with 14xh plus 7h in the numerator, and we can take the common factor of h out from the numerator. We get h times 14x plus 7h. By the way, I can take out 7h, but I don't want to. I just want to get rid of the h, everybody. Again, please understand, a proper factoring, we take 7h out. I don't want to do that. Now, because you really don't have to for this case. When h is 0, the answer is 14x. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4d, where t is time in seconds. What is the average velocity of the object from 2 to 4? This is 2 to 4 seconds. This is elementary algebra, okay? Which is, by definition, total distance over total time. If you cover 100 miles over the course of 2 hours, you get 50 miles per hour. That's the idea. So S of T2 minus S of T1 over T2 minus T1. And that means S of 4 minus S of 2 over 4 minus 2. This is elementary algebra. Plug in 4, plug in 2, evaluate it. So when we plug in 4, we get 2 times 4 squared minus 5 times 4 plus 40. Minus, when we plug in 2, we get 2 times 2 squared minus 5 times 2 plus 40. This is 16. You get 32 minus 20 plus 40, and that would be 52. This is 4. 2 times that is 8 minus 10 plus 40 is 38. So we have 52 minus 38 in the numerator, which is 14 over 2 or 7 feet per second. So that was elementary. What is the instantaneous velocity of the object at 4 seconds? Before we come up with the answer, again, I want you to see the difference. Even if they don't mention average from 2 to 4, 2 points in time, versus even if they don't mention instantaneous, 1 point in time. 1 point in time means instantaneous, means differentiation. So V of instantaneous. Of course, later on we use formulas, but for now, S of A plus H minus S of A over H when we take a limit as H approaches 0. Again, bear in mind we are using definitions, okay? Later on we use formulas. And so what is A? A is 4, everybody. So we replace the A with 4. And what is f of S of 4 plus H? Plug in 2 times 4 plus H squared minus 5 times 4 plus H plus 40 minus S of 4. You can calculate that. Or remember, S of 4 was 52. We have done S of 4. You don't have to waste your time. You can just use that. So the fact that S of 4 has been calculated, make a note of it. Now, of course, this is 4 squared or 16 plus 2 times 4 times H plus 8H plus H squared. We are going to distribute the 2, resulting in 32 plus 16H plus 2H squared minus 20 minus 5H plus 40 minus 52. (32) and negative 20 and 40 and minus 52. They add up to 0. They cancel each other. The numerator has a 2H squared plus 11H. So we factor out the H. And we take a limit of 2H plus 11 as H approaches 0, which is 11 feet per second. As far as the units are concerned, units of the numerator over the units of denominator, feet per second. V is dV dt, the units of the numerator over the units of the denominator, the same thing. Find an equation of a tangent line to the parabola y equals x squared at the point P with coordinates 1, 1. To find an equation of any line, we need two things. We need the slope and we need a pair. The pair is given. So how do you find the slope? You have to take the derivative. To take the derivative, we are going to use the definition because we are not there yet that we can use the formulas. And in fact, there are two definitions, and I'm going to do both for practice this time. So if we use, and you figure out one is easier than the other, this is more often used in general. So if we use the first one, okay, we know a is 1, and we want the limit of f of x minus f of a over x minus a as x approaches a. We are going to use this definition, and I'm going to use that definition also to find this loop. So we want m or f prime of 1, which means replace the a with 1. F of x is x squared, and f of 1, you can plug it in, or f of 1 is given because it's point with coordinates 1, 1. A numerator can be factored into x minus 1, x plus 1. These two cancel each other. And we get limit of x plus 1 as x approaches 1, and you plug in, you get 2. Now, this is the part that I'm going to look at it a second method in a moment. But for now, y minus y1 equals m times x minus x of 1, which means y minus 1 equals m, or 2 times x minus 1. And of course, class, this is 2x minus 2 minus 1 goes to the other side, plus 1, and we get 2x minus 1. We are done. We don't have to do the second way. I just wanted to show you using the second method for practice. All I'm interested in is to calculate this slope, where a is the x coordinate of the pair, or 1. Pair comma x comma 1. What is f of 1 plus h? You plug it into this one, it becomes 1 plus h squared, minus what is f of 1 is 1. And 1 plus h quantity squared is 1 squared, or 1, plus 2 times the first term times the last 2h, plus h squared. 1 and negative 1 cancel each other. From the numerator, I can take the h out. These two cancel each other. And I get the limit of 2 plus h as h approaches 0. If I replace the h, I get the same 2. This, of course, I don't have to repeat. The point of this was to show you two different ways resulting in the same thing. And again, do you have to do both ways? Absolutely not. And again, I'm emphasizing, for now, for this exam, we are using definitions. Find the equation of a tangent line to the graph of f of x equals square root of x at the point P with coordinates 16, 4. By the way, they may give you the x coordinate only. Please understand, if you plug in 16, you get 4. And you should come up with the pair. So obviously, a is 16, and f of x is square root of x, and we are going to use one of these definitions. A is 16, f of x square root of 16. And let's go with the more formal definition that is used, and replace the a with 16, everybody. Which means we are going to write f of 16 plus h, that means square root of 16 plus h. F of 16, you can write as square root of 16, or you write 4. I'm going to write square root of 16 on purpose, just in case if we didn't have it and it wasn't given and you had to calculate. And obviously, if you plug in, you get 0 over 0. The technique is to multiply by the conjugate. So you multiply and divide by the conjugate of the numerator. That means change this to a plus sign, put it at top as well as the bottom. The denominator is just the product of these two. We don't touch it. And again, you can keep it as square root of 16 or change it to 4. It doesn't matter. But the top is, when you multiply these two, you get square root of 16 plus h, quantity squared, minus square root of 16, quantity squared. That's what you get. These two cancel each other. H and H cancel each other, and the numerator becomes 1. If you replace the H with 0, you get square root of 16. This is 4. This is 4. You get 1 over 8. Y minus y1 equals m times x minus x of 1. So plug in, where you have the pair here, y minus 4 equals m, which we found it to be 1 over 8 x minus 16. And we can see that this is 1 over 8 times x, and this is what? Minus 2. You have to move the negative 4 to make it positive 4, and negative 2, they add up to positive 2. And you're done. Y equals 1 over 8 x plus 2. That's the equation of a tangent line. However, I want to show you how to find the slope with the other one, f prime of a equals to the limit of f of x minus f of a over x minus a. Just for practice, you don't have to do both ways. So f of x is this, f of a is 4, and x minus a. So just replace the a with 16, that's all. And you know f of 16 is 4. Now, because you're dealing with the square root, if you plug in 16, by the way, you should get 0 over 0, which is indeterminate. The technique is to multiply by the conjugate of the numerator, which is square root of x plus 4, and divide by it. So the numerator will give you x minus 16. The denominator you never ever distribute. You just keep it the way it is. So we didn't do anything to the denominator. Clearly, we can drop x minus 16. And we get this one. I hope you realize if you put 16 here, you get 4 and 4, 8. So 1 over 8. We get to the same answer. Okay. As expected here. Same answer here. But we should be able to do both ways. Okay.